Biconditional statement. It is a conjunction of a conditional statement and its converse. A biconditional statement, P if and only if Q is equivalent to P implies Q and Q implies P, or it can also be written in this way. It is read also as P implies Q and. This symbol means and. Q implies P. When written, if and only if may also be abbreviated as IFF. A biconditional statement is true whenever the statements P and Q have the same truth value. That is, P if and only if Q is true either when P and Q are both true or when P and Q are both false. Otherwise, our biconditional statement is false. Okay, so we're going to write the following statement in biconditional form. Then we will identify its truth value. So take this given. Perpendicular lines form right angles. So we will use a table to organize our answer. So we can immediately write the biconditional form of our given, and that is by simply inserting this phrase, if and only if, in our given. So lines are perpendicular if and only if they form right angles. Okay, so to identify its truth value as of the moment, we need to find first the conditional statement of our given. And from this given, our conditional statement will be, if lines are perpendicular, then they form right angles. So question, is it true or false? If lines are perpendicular, of course, they will form a 90-degree angle. Then, a 90-degree angle is a right angle. So we can say that it is true. This conditional statement is true. Okay, how about the converse statement of this given? So we will just simply reverse the conclusion and the hypothesis for our converse. So if the lines form right angles, then they are perpendicular. Question, is it true or false? If the two lines will form a right angle and that right angle measures 90 degrees, wherein perpendicular also measures 90 degrees, therefore, our truth value is true for this converse statement. Now, if the conditional statement and the converse statement are both true, we can conclude that the biconditional statement is also true. Okay, for our given number 2, our first statement represented by P is a polygon has more than 3 sides. Then our second statement is a polygon is a quadrilateral. Now, we're going to write the biconditional statement of this given. We will just simply insert if and only if, or you can use the abbreviation IFF. So a polygon has more than 3 sides if and only if, second statement, it is a quadrilateral. So to identify its truth value, we need to find first the conditional statement of this given. So we can use this as our hypothesis. If a polygon has more than 3 sides, then for the second statement, this will be our conclusion. It is a quadrilateral. Question, is it true or false? If a polygon has more than 3 sides, so what are the polygons more than 3 sides? So it can be quadrilateral, so it might be true. But it can also be pentagon, hexagon, heptagon, octagon, and so on. So therefore, we can say that the truth value for the conditional statement is false. How about its converse statement? So we'll just simply interchange the if and then. So this will be our if. If a polygon is a quadrilateral, then our conclusion will be the hypothesis of our conditional. Then it has more than 3 sides. So let us now analyze our converse statement. If a polygon is a quadrilateral, okay, so when we say quadrilateral, it is a polygon with 4 sides. Then it has more than 3 sides. Do you agree? Yes, because quadrilateral or a 4-sided figure has more than 3 sides. So we can say that this converse statement is true. Now, for our biconditional statements, since the conditional and converse are not the same, we can say that the truth value of our biconditional statement is false.